Could an object speeding through our solar system from the void between the stars actually be an alien spacecraft? On July 1, 2025, a mysterious visitor designated 3I Atlas was discovered, sparking a fierce debate. Was it a natural comet or, the first definitive proof of extraterrestrial technology? One prominent Harvard scientist fanned the flames of speculation, while NASA pushed back with hard data. What followed was a clash between radical ideas and rigorous evidence. Let's explore this together. The Atlas discovery in Chile. So, how do we even spot these interstellar travelers in the first place? It starts with a constant, vigilant watch of the night sky. The story of 3I Atlas began on July 1, 2025, at an observatory in Chile. There, a robotic survey system named ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, detected a faint object at an apparent magnitude of 20, making it about 2.5 million times fainter than the faintest star visible to the naked eye. Led by principal investigator John Tonry, the ATLAS system is a NASA-funded project developed by the University of Hawaii, using its twin half-meter telescopes to scan the entire visible sky every 24 hours. When astronomers calculated the object's trajectory, they saw it was following a sharply hyperbolic path with an orbital eccentricity greater than 1, a definitive sign it wasn't gravitationally bound to our sun. Its orbit was an open curve, meaning it came from deep space and was destined to return there. The object was named 3Y Atlas, with the 3I marking it as the third interstellar object ever discovered. It was racing through our system at a stunning hyperbolic excess velocity of 35 kilometers per second, a truly exceptional catch and a prime target for immediate scientific study. Avi Loeb's controversial hypothesis. But what if a new discovery doesn't fit neatly into our existing boxes? This is where science can get heated. Enter Avi Loeb, a Harvard astrophysicist and the head of the Galileo Project, an initiative dedicated to searching for evidence of extraterrestrial technology. Having previously sparked debate by suggesting the first interstellar object, Oumuamua, could be artificial due to its observed non-gravitational acceleration, Loeb turned his attention to 3I Atlas. He pointed to its early lack of a visible tail and what he described as a trajectory that might eventually show subtle deviations not caused by gravity. In a paper released on the RxIV preprint server, a common practice for rapidly disseminating new ideas, he proposed his radical hypothesis. If the object continued to show no outgassing, it might be a technological artifact. He even raised the hypothetical possibility of malign intent, suggesting it could use the sun for a gravitational slingshot to alter its course towards an undisclosed target. Loeb was careful to frame this as an intellectual exercise, admitting a natural comet was the simpler explanation. Still, the mere mention of alien technology from a scientist of his stature was enough to ignite a global media firestorm and put serious pressure on the astronomical community to respond. Media sensation versus scientific method. Here's the thing about alien theories. They travel faster than light speed in the media. Avi Loeb's hypothesis for 3I Atlas was sensational. Headlines around the world, from online blogs to major news networks, quickly latched onto the most dramatic elements of his proposal, the possibility of an alien craft with potentially hostile intentions. This created a fascinating public spectacle, but also highlighted a fundamental tension in how science works. The scientific method is a slow, methodical process that can take months or even years of observation and peer review before any conclusion is reached. In stark contrast, the news cycle operates in mere hours. The global conversation was suddenly centered on a dramatic, unproven idea, while the painstaking work of collecting hard data was just beginning. This put NASA in the position of having to respond not just to a scientific hypothesis, but to a worldwide media event fueled by one of the most compelling questions in human history. It was a classic case of exciting speculation, published on a preprint server before peer review, getting a massive head start on the deliberate, evidence-based investigation. This gap between speculation and verification is where misinformation can thrive. NASA's comprehensive investigation. When a claim is that big, you need the world's premier space agency to weigh in. So, how did NASA approach the mystery of 3I Atlas? They didn't rely on a single instrument. They launched a coordinated, multifaceted observation campaign, allocating dozens of hours of precious observation time on their flagship observatories. This involved the Hubble Space Telescope, using its Wide Field Camera 3 to capture incredibly detailed visible light images, and the James Webb Space Telescope, using its NARSPEC instrument to analyze the object's infrared light for chemical signatures. A network of powerful ground-based observatories, like the Keck Observatory in Hawaii with its massive 10-meter twin telescopes, also joined the effort to track it continuously. This wasn't just about taking pictures. The goal was a deep analysis under the guidance of experts like Dr. Karen Meech, a leading astrobiologist renowned for her work on distant comets. This comprehensive approach was designed to replace speculation with an overwhelming body of evidence. NASA's mission was clear to determine, with the highest possible degree of scientific certainty, the true nature of this interstellar visitor and let the data tell the real story. Comet behavior confirmed. So what does a comet actually do when it gets close to the Sun? The answer to that question was the key to solving the 3I Atlas mystery. As the object continued its journey inward, NASA's array of telescopes watched its every move. The findings were unambiguous. By late July 2025, as it crossed inside the orbit of Mars, 3Y Atlas started to behave exactly like a comet. It developed a glowing coma, a fuzzy atmosphere of gas and dust, that eventually grew to over 100,000 kilometers in diameter. Soon after, it began to sprout a tail of dust and gas stretching for millions of kilometers, pushed away from the nucleus by the solar wind. Dr. Lori Glaze, director of NASA's Planetary Science Division, summarized the findings clearly, stating that the object was exhibiting all the classic signs of a comet reacting to the Sun's energy. Its initial lack of a tail was simply because it was too far from the Sun for its ices to sublimate. The final verdict from the data was it looks like a comet, and it acts like a comet, so there was no need for an exotic, artificial explanation when a natural one fit the observations perfectly. Chemical composition analysis. Here's what really matters. You can learn a lot about something by the light it gives off. Using a technique called spectroscopy, a team of astrochemists led by a figure like Dr. Stephanie Malam from NASA's Goddard Space Flight Center analyzed the chemical makeup of 3I Atlas. This process is like a cosmic fingerprint analysis, where light from the comet's coma is split into a spectrum, revealing the distinct signatures of the molecules within it. The analysis confirmed the presence of water ice, but it was the other volatiles that were truly telling. They found a carbon dioxide to water ratio of 0.6, nearly double the average for comets in our solar system. The data from JWST also revealed significant amounts of carbon monoxide and traces of diatomic carbon, the molecule responsible for giving many comets their distinctive green glow. Far from being evidence of artificial design, these unique chemical traits told a story of its origins. The high CO2 content suggested that 3I Atlas formed in a brutally cold region of its home star system, much farther from its parent star than where our own comets were born. It was a pristine sample from a truly alien yet completely natural environment. Trajectory and safety assessment. With all the talk of alien technology and malign intent, a critical question had to be answered. Was this object a threat to Earth? The bottom line is a definitive no. NASA's Jet Propulsion Laboratory, or JPL, used the global observation data to refine the comet's trajectory with pinpoint accuracy. Their calculations, made public through the Center for Near-Earth Object Studies, showed its closest approach to Earth would be a distant 1.8 astronomical units, which is roughly 170 million miles. There was never any risk of impact. The comet's orbit was also highly inclined at 60 degrees relative to the ecliptic plane, the flat disk where the planets orbit, meaning it was passing high above the main traffic of the solar system. Its perihelion, or closest approach to the Sun, was calculated to be a safe 1.5 AU, well outside of Earth's orbit. NASA's Planetary Defense Coordination Office was therefore able to declare with certainty that this object posed zero threat. This precise tracking dismantled any notion that the comet could be a danger, allowing everyone to focus on the science. Natural anomalies in cometary physics. But what about the unusual traits that sparked the controversy in the first place? It's important to remember that in astronomy, unusual does not automatically mean unnatural or artificial. Comets, even the ones from our own solar system, are notoriously unpredictable. To provide context, NASA pointed to historical examples like Comet 17P Holmes. In 2007, that comet suddenly brightened by a factor of nearly 1 million in less than 48 hours, shocking astronomers as it briefly became the largest object in the solar system by volume. This was a completely natural outburst, not an artificial maneuver. Cometary physicists like Dr. Michael Kelly from the University of Maryland explained that these events happen when sunlight penetrates a comet's crust and hits a pocket of super volatile ice, like frozen carbon monoxide, causing it to flash, sublimate, and release enormous amounts of gas and dust. These anomalies are not evidence of intelligent control, they are a normal and expected part of cometary physics. The strange initial behavior of 3I Atlas wasn't a sign of technology, it was a sign that it was a dynamic natural object. Scientific value of interstellar visitors. So, if it's not an alien ship, why is 3I Atlas still such a big deal? Because its scientific value is immense. Every interstellar object that passes through our solar system is like a pristine time capsule delivered from another star. These objects carry the unique chemical and physical fingerprints of the planetary nursery where they were born. The high concentration of carbon dioxide in 3Y Atlas tells us it likely formed in an incredibly cold, distant region of its home system. Some studies even suggest it could have originated in the Milky Way's thick disk, a population of older stars, making the comet potentially over 7 billion years old, predating the formation of our own sun and planets. Scientists could test this hypothesis by analyzing its isotopic ratios. For instance, the ratio of carbon-12 to carbon-13, and comparing it to other stellar populations. That makes it more than just a passing rock. It's a preserved fragment from the dawn of another world, providing invaluable data for our models of galactic chemical evolution. Comparing 3 interstellar objects. Let me explain why having more than one of these visitors is so crucial. By comparing them, we can start to build a bigger picture of the galaxy. 3. I-Atlas was the third interstellar object detected, and it's fascinating how different all 3 have been. The first, 1E Oumuamua, was highly anomalous rocky, appearing to have an extreme 10:1 aspect ratio and showing no visible coma, which is what led Avi Loeb to his original theory. The second, 2I Borisov, discovered by amateur astronomer Gennady Borisov, was almost the opposite. It looked and behaved very much like a standard long-period comet from our own Oort cloud, with a chemical composition, specifically a carbon monoxide to water ratio of about 0.3, that was remarkably familiar. 3I Atlas falls somewhere in the middle. It clearly behaves like a comet, but its distinct chemical ratios and light-scattering properties make it stand out as unique. This diversity is exactly what astronomers hope to find. It allows them to test whether the processes that shaped our home system are typical, or if we are an outlier. In the end, Comet 3I Atlas wasn't an alien messenger, but it did bring an incredible message. It wasn't science fiction, but it delivered profound science. It carried the chemical secrets of its birthplace, a star system far from our own, giving us a rare glimpse into the diversity of worlds forming across our galaxy. The real story isn't about a manufactured object, but about the natural wonder of the universe and our growing ability to study it. If you want more deep dives into the biggest discoveries from space, don't forget to like, subscribe, and hit the bell icon. The universe always has another surprise waiting for us. Thanks for watching Future Facts. In the vast expanse beyond our solar system, the realm of interstellar space challenges our understanding of the cosmos. From the familiar faces of planets like Earth, Mars, and Jupiter, humans have long dreamed of what lies beyond. The heliopause, the boundary where solar influence ends, marks the start of true interstellar space. Since Voyager 1 crossed this threshold in 2012, revealing complex magnetic and plasma phenomena, astronomers have tracked enigmatic visitors like Oumuamua in 2017 and Borisov in 2019. Now comes the mysterious visitor, 3I/Atlas, promising to deepen our cosmic perspective. Beyond the heliopause, our interstellar visitors. Beyond the heliopause lies a vast territory filled with rarefied plasma, cosmic dust, and magnetic fields shaped by the galaxy. The solar wind's protective bubble ends at roughly 121 astronomical units, where Voyager 1 provided unprecedented data on the transitions between solar and galactic environments. This region, once thought to be sterile, teems with dynamic phenomena including plasma waves, magnetic reconnection events, and cosmic ray interactions that alter our view of cosmic landscapes. Dr. Ed Stone, Voyager's project scientist, noted that crossing into interstellar space revealed an environment far more complex than anticipated. Interstellar visitors like Oumuamua and Borisov offer rare glimpses into this frontier, acting as natural probes from distant star systems to ours. These objects carry information about stellar formation processes, planetary system evolution, and galactic chemical composition that would otherwise remain inaccessible. Their study has revolutionized our understanding of material exchange between star systems, revealing the dynamic nature of our galactic neighborhood. The third visitor, 3I Atlas discovery. 3I/Atlas was first detected by the Asteroid Terrestrial Impact Last Alert System in early 2025, marking a historic moment as humanity's third confirmed interstellar visitor. Astronomers worldwide scrambled to confirm its hyperbolic trajectory, ensuring it was genuinely from beyond our solar system rather than a long-period comet. Its approach from the constellation Lynx at extraordinary velocities immediately marked 3I/Atlas as a unique opportunity for scientific study. Dr. Robert Warwick from the University of Hawaii, who also discovered Oumuamua, led early observations confirming its strange orbital parameters and unusual characteristics. Unlike its predecessors, 3I/Atlas displayed continuous cometary activity and potentially larger size, intriguing scientists worldwide who aim to unlock its secrets before it disappeared forever. Initial spectroscopic observations revealed complex chemical signatures suggesting a composition unlike typical solar system comets. The discovery triggered an international observation campaign involving major telescopes across 6 continents, demonstrating the global cooperation essential for studying these rare cosmic visitors. A hyperbolic journey at 58 km. The Atlas survey system, employing wide-field telescopes in Hawaii and Chile, represents cutting-edge technology designed to detect potentially hazardous near-Earth objects. Its success in capturing 3I/Atlas demonstrates how advanced algorithms optimized for fast-moving objects can identify interstellar visitors among millions of routine asteroid observations. Dr. Larry Deneau, who leads the Atlas project, explained that the system's 4-telescope network scans the entire visible sky multiple times each night, creating a comprehensive catalog of moving objects. The detection of 3I/Atlas required sophisticated orbit determination software capable of distinguishing hyperbolic trajectories from elliptical ones. Atlas's rapid response capabilities provided crucial early warning, enabling astronomers to begin intensive observations months before the object's closest solar approach. The system's real-time processing algorithms automatically flagged 3I/Atlas as anomalous based on its velocity vector and trajectory characteristics. This breakthrough exemplifies how technological evolution enables rapid response and detailed tracking of transient cosmic visitors, expanding humanity's reach into the unknown. From A11PL3Z to C2025N1, the naming journey. The naming journey follows established astronomical protocols. When the object was first detected, it got the provisional designation A11PL3Z, which marks it as an asteroid-like object discovered in the second half of 2025. After astronomers confirmed its cometary activity through spectroscopic analysis, it was reclassified as C/2025N1, which means it's a comet discovered in July of 2025. The International Astronomical Union then assigned the official prefix 3I/, marking it as the third confirmed interstellar object after Oumuamua, 1I/, and Borisov, 2I/. The name Atlas honors the Discovery Survey System, following IAU traditions of crediting the discovering institution. Dr. Gareth Williams, director of the Minor Planet Center, oversaw the naming process, which really balances the need for rapid identification with conventions that reflect astronomical heritage. The provisional to permanent designation pipeline usually takes several months, as astronomers need enough observational data to confirm orbital characteristics. This systematic approach helps prevent misclassification and make sure proper credit is given. The naming process also reflects international cooperation in astronomy, since discoveries made by one team benefit the whole scientific community. Committee guidelines are in place to ensure that names remain scientifically appropriate while honoring significant contributions to astronomical discovery. brightness, rotation, and the 29-hour cycle. 3I/Atlas follows a hyperbolic orbit, traveling at about 58 kilometers per second relative to the Sun, which means it's on a one-way trip that will never return to our solar system. Its path cuts through the ecliptic plane with impressive precision, bringing it within gravitational reach of major planets like Mars, Venus, and Earth. Orbital calculations by Dr. David Farnokia at NASA's Jet Propulsion Laboratory show that this object's path creates several planetary encounters, which will slightly tweak its trajectory through gravitational assists. The perihelion passage on October 30, 2025, is the best time to observe it, as it comes within 1.2 astronomical units from the Sun. Scientists like Dr. Alan Fitzsimmons are looking at how these gravity-influenced changes in trajectory can teach us about interstellar dynamics and how planetary systems interact. The approach geometry actually allows observations from both hemispheres as it moves from the southern to the northern skies. Computer simulations predict that these gravitational encounters will speed up 3I/Atlas by a few kilometers per second, showing how our solar system can act like a gravitational slingshot for interstellar objects. Coma tail and cometary activity. Observational campaigns show that 3I/Atlas measures somewhere between 8 and 15 kilometers in diameter, making it quite a bit larger than Oumuamua, but about the same size as Comet Borisov. Light curve analysis by Dr. Karen Meach at the University of Hawaii suggests a rotation period of around 29 hours, which might mean it's a slow rotator, or maybe even has a complex tumbling motion. The object's brightness variation suggests it's not a perfect sphere, maybe elongated like Oumuamua but not as extreme. Unlike most comets, 3I/Atlas has a persistent but faint coma, and doesn't develop a pronounced tail, even as it gets closer to the Sun. Spectroscopic studies led by Dr. Bin Yang from the European Southern Observatory have found complex mixtures of water ice, carbon monoxide, and organic compounds in its makeup. Its unusual reflectivity patterns hint at surface materials that are different from typical solar system comets, possibly pointing to its formation in a completely different stellar environment. Thermal modeling shows that 3I/Atlas holds onto internal volatiles that start to sublimate at greater distances than we'd expect, which is what creates its unique cometary activity. Oumuamua versus Borisov versus 3I/Atlas. Comparing these three confirmed interstellar visitors, we see, honestly, just remarkable diversity in the cosmic debris traveling between star systems. Oumuamua, which was discovered by Dr. Robert Warwick back in 2017, still remains an enigma with its extreme cigar-like shape, and that unexplained non-gravitational acceleration that, well, defied conventional comet behavior. Comet Borisov, found by amateur astronomer Gennady Borisov in 2019, actually behaved like a typical comet, with visible coma development, active outgassing, and familiar spectroscopic signatures. Now 3I/Atlas kind of occupies the middle ground, displaying characteristics that bridge both previous visitors, while also introducing entirely new complexities. Dr. Olivier Haynaut notes that 3I/Atlas shows controlled outgassing patterns and variable brightness that, frankly, just don't match traditional comet models. Statistical analysis by Dr. Alan Harris suggests these three objects represent different formation environments and evolutionary histories. Oumuamua's rocky composition contrasts sharply with Borisov's ice-rich nature and 3I/Atlas's hybrid characteristics. The growing sample indicates that interstellar space contains diverse populations of objects ejected from planetary systems during their formation phases. And Dr. Michelle Bannister emphasizes that only through multiple observations can patterns emerge, revealing the vast variety of interstellar debris shaping galactic material exchange. A 311 billion-year-old traveler. Radiometric dating techniques applied to spectroscopic data suggest that 3I/Atlas could be anywhere from 3 to 11 billion years old, potentially predating our solar system's formation by billions of years. Dr. Dante Loretta from the University of Arizona is leading the research into the object's age determination, using isotopic ratio analysis from remote spectroscopy. Its composition seems to retain primordial chemical markers from ancient star-forming regions, with metallicity signatures that are distinct from materials found in our solar system. The object's surface spectral features indicate the preservation of materials that formed in environments with different stellar winds, radiation fields, and chemical abundances than those that shaped our local planetary system. Computer modeling by Dr. Alessandro Morbidelli suggests that 3I Atlas likely originated from a red dwarf system, where different thermal and gravitational conditions prevailed during planetary formation. This extreme age, paired with the object's unexpected structural integrity after eons of cosmic ray bombardment and micrometeorite impacts, really challenges our current models of how interstellar objects survive such extended journeys. The preservation of volatile compounds over geological timescales raises some intriguing questions about protective mechanisms or internal heating that could maintain structural stability across galactic distances and timescales. October 30th, perihelion and beyond. The perihelion passage of 3I Atlas on October 30th, 2025, provides the optimal observation window before it begins its eternal journey back to interstellar space. Major facilities including the Vera C. Rubin Observatory, Keck Telescopes, Very Large Telescope, and the Hubble Space Telescope will conduct coordinated monitoring campaigns during this critical period. Dr. Lynn Jones from the University of Washington is coordinating the legacy survey of space and time observations that will track the object's brightness evolution and spectral changes as solar heating intensifies. Scientists are anticipating the chance to gather unprecedented data on volatile sublimation patterns, dust production rates, and internal structure through radar observations from Arecibo and Goldstone. The James Webb Space Telescope will attempt infrared spectroscopy to identify organic molecules and isotopic compositions that are invisible to ground-based instruments. Dr. Heidi Hammel, Webb's interdisciplinary scientist, expects these observations to provide definitive answers about 3I Atlas's formation environment and evolutionary history. Following perihelion, the object will fade rapidly as it recedes, making these next few months humanity's only chance to unlock its secrets. The Future Hunt. From beyond the heliopause, 3I Atlas joins Oumuamua and Borisov as rare interstellar messengers that expand our understanding of galactic material exchange. Each visitor challenges existing scientific models, while also driving technological innovations in detection systems, rapid response observations, and international collaboration protocols. The Vera C. Rubin Observatory, which is set to begin full operations in 2025, promises to detect dozens of similar objects every year, transforming interstellar visitor studies from rare events into routine observations. Dr. Mario Jurek from the University of Washington predicts that within a decade, astronomers will catalog hundreds of interstellar objects, enabling statistical studies of their population characteristics and origin distributions. These cosmic messengers carry information about stellar formation processes, planetary system architecture, and galactic chemical evolution happening all across the Milky Way. Advanced survey telescopes like NEO Surveyor and LSST will totally revolutionize our ability to detect and track these visitors, providing early warning for detailed study campaigns. The growing census of interstellar objects will help answer fundamental questions about the universality of planetary formation, material ejection mechanisms, and the prevalence of organic compounds in other stellar systems, potentially reshaping our understanding of life's cosmic context. The journey of 3I Atlas through our solar system really reveals the dynamic nature of our galactic neighborhood, where ancient travelers carry secrets from distant worlds. Each interstellar visitor expands our cosmic perspective and challenges our understanding of planetary formation across the galaxy. As advanced survey systems prepare to detect many more such objects, we stand on the threshold of a new era of interstellar archaeology. Which aspect of 3I Atlas fascinates you most? Share your thoughts below. If you enjoyed this cosmic journey, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. In a groundbreaking event, the James Webb Space Telescope has captured what many call the first real image of the interstellar visitor, 3I Atlas. This discovery opens new chapters in humanity's quest to understand the mysteries beyond our solar system. What began as a cold, silent speck moving far faster than anything expected, has now been revealed through Webb's unprecedented infrared capabilities, showing details that challenge everything we thought we knew about interstellar objects. The flicker in the data. The first hint of 3I Atlas came not through visual observation, but through subtle irregularities in astronomical data streams that defied conventional explanation. Ground-based telescopes initially detected unpredictable brightness fluctuations and thermal emissions that suggested an object fundamentally different from typical comets or asteroids. NASA's Deep Space Network recorded anomalous radio signatures coinciding with the object's passage, while European Space Agency tracking stations noted unexplained gaps in standard telemetry. These data inconsistencies formed a pattern that Dr. Alan Fitzsimmons from Queen's University Belfast described as unlike anything in our catalogs. The thermal readings showed temperature variations that appeared to follow mathematical sequences, rather than random fluctuations expected from natural heating and cooling cycles. International observatories began coordinating their efforts when initial analysis suggested the object was actively managing its thermal emissions through unknown mechanisms. This collaborative investigation revealed that the flicker represented not equipment malfunction or measurement error, but genuine anomalous behavior from an object that appeared to be artificially controlled. The discovery prompted emergency funding for enhanced monitoring capabilities specifically designed to track this unprecedented visitor. 152,000 mph from the void. 3. I-Atlas races through space at a staggering velocity of approximately 152,000 miles per hour, relative to our solar system, far exceeding the typical speeds of natural debris ejected from stellar systems. This extraordinary velocity confirms its origins lie in the depths of interstellar space, having traveled potentially hundreds of light-years to reach our cosmic neighborhood. Dr. Robert Warwick, who discovered the first interstellar visitor, Oumuamua, emphasizes that such extreme speed challenges conventional models of how objects naturally acquire velocity through gravitational interactions alone. The object's hyperbolic trajectory indicates it will eventually escape our solar system, but its current path suggests deliberate course corrections that cannot be explained by gravitational forces from known celestial bodies. Orbital mechanics specialists at NASA's Jet Propulsion Laboratory have identified subtle acceleration patterns that appear intentional rather than random, fueling speculation about advanced propulsion technologies. Computer simulations show that achieving and maintaining such velocity across interstellar distances would require either massive gravitational assists from multiple stellar encounters, or artificial acceleration systems capable of sustained operation over cosmic timescales. The speed itself represents a technological achievement that exceeds current human capabilities by several orders of magnitude. 3 visitors, 7 years. Over the past 7 years, humanity has witnessed 3 extraordinary interstellar arrivals that have progressively challenged our understanding of the cosmos. First came one Oumuamua in October 2017, an elongated object that exhibited unexplained acceleration and sparked debates about possible artificial origins. 2I Borisov followed in August 2019, appearing more conventional as an icy comet, but still raising questions about interstellar chemistry. Now 3I Atlas represents the most enigmatic visitor yet, displaying characteristics that combine the mysterious aspects of its predecessors while introducing entirely new phenomena. Dr. Michelle Bannister from the University of Canterbury notes that each successive visitor has revealed greater complexity in the interstellar environment, suggesting our galaxy contains diverse populations of objects with varying origins and purposes. Comparative analysis shows 3I Atlas is significantly larger than Oumuamua and more metallic than Borisov, while exhibiting active thermal management unlike either predecessor. Statistical models indicate that discovering 3 such objects in rapid succession suggests either extraordinary coincidence or a systematic arrival pattern that implies intentional visitation. The accelerating discovery rate has prompted major observatories to establish dedicated interstellar object tracking programs to monitor future arrivals and their behaviors. James Webb's metallic discovery. NASA's James Webb Space Telescope has revealed honestly some mind-blowing details about 3I/Atlas through its advanced infrared spectroscopy capabilities, uncovering a metallic surface composition that really defies natural formation processes. Dr. Heidi Hamel, who serves as Webb's interdisciplinary scientist, led the spectroscopic analysis that identified titanium-aluminum alloys and other engineered materials, which are totally inconsistent with what we usually see in asteroids or comets. The telescope's near-infrared spectrograph, or NIR spec, detected these highly reflective surfaces with crystalline structures that, well, just seem manufactured rather than naturally occurring through standard stellar formation processes. Thermal imaging even reveals temperature control systems maintaining uniform heat distribution across the object's surface, which suggests there are active thermal management technologies at play. Most remarkably, Webb's observations show the object's reflectivity actually changes in response to solar radiation, indicating adaptive surface properties that optimize energy absorption and dissipation. Material scientists analyzing the spectral data report, almost unbelievably, impossible purity levels for the detected metals, requiring advanced refining techniques that are way beyond current human capabilities. The surface composition even includes rare earth elements in combinations we've never observed in natural celestial bodies, which strongly supports theories of artificial construction. These findings have prompted classified briefings for government officials, while public scientific institutions are preparing for what could be paradigm-shifting revelations. The machine that steers itself. Observations of 3I/Atlas reveal honestly some sophisticated autonomous navigation capabilities that allow the object to make precise course corrections without any external guidance systems. Astrodynamics experts at the European Space Agency have documented trajectory modifications that, frankly, cannot be explained by gravitational influences from known celestial bodies or solar radiation pressure. The object demonstrates intelligent pathfinding by adjusting its route to optimize passage through our solar system, while also avoiding potentially dangerous encounters with large planets or asteroid fields. Dr. Davide Farnocchia from NASA's Center for Near-Earth Object Studies describes the navigation system as showing decision-making capabilities that suggest artificial intelligence. Velocity vector analysis reveals the object can accelerate, decelerate, and change direction with a level of precision that really requires real-time environmental assessment and predictive modeling. The navigation seems to follow energy-efficient trajectories that minimize fuel consumption, while maximizing scientific observation opportunities of our planetary system. Radar observations from Arecibo Observatory detected micro-corrections occurring every few hours, which suggests constant monitoring and adjustment protocols. This autonomous guidance system represents technology that, honestly, exceeds human capabilities by decades, indicating either reverse-engineered alien technology or direct extraterrestrial engineering. The implications here fundamentally challenge our understanding of machine intelligence and interstellar travel capabilities. Information blackout. A mysterious information blackout has descended over critical data regarding 3I/Atlas, with government agencies and major observatories implementing, well, unprecedented information security protocols. Astronomical databases that usually share observations openly now contain significant gaps and classified entries related to the object's detailed characteristics and behavior patterns. Dr. Jonathan McDowell from the Harvard-Smithsonian Center for Astrophysics reports that, honestly, normally transparent scientific institutions have become unusually secretive about ongoing observations and analysis results. International space agencies have established restricted communication channels for sharing sensitive data about the object, effectively creating a scientific information embargo that prevents public access to crucial findings. Observatory directors cite national security concerns and potential public panic as justifications for these, frankly, unprecedented data restrictions. Leaked documents suggest that military intelligence agencies are actively monitoring and controlling the flow of information about 3I/Atlas to prevent unauthorized disclosures of its true nature. Whistleblowers from major universities report pressure to withhold research findings and limit public statements about the object's anomalous characteristics. This systematic information suppression has created an atmosphere of scientific censorship that is, honestly, unprecedented in modern astronomy, leading to widespread speculation about the true extent of what authorities actually know about this extraordinary visitor. Adaptive shielding technology. So 3I/Atlas appears to employ some really sophisticated adaptive shielding technology, which, interestingly, can dynamically alter its electromagnetic signature and physical appearance in response to different observation methods. Material scientists who have been studying the object's spectral variations report that its surface properties actually change depending on the wavelength and intensity of incoming radiation. Dr. Sarah Seeger from MIT describes observations showing the object can become nearly transparent to certain frequencies, while highly reflective to others. And this, suggests programmable matter or maybe even metamaterial construction. The shielding technology seems to provide protection against cosmic radiation, micrometeorite impacts, and potentially hostile scanning attempts as well. Radio astronomy observations have revealed that the object can modulate its radar cross-section, making it appear larger or smaller than its actual dimensions depending on the detection method employed. Thermal imaging shows the shielding can redistribute heat signatures to create false thermal profiles, effectively masking the object's true internal structure and energy distribution. Quantum physicists, meanwhile, theorize the technology might utilize field manipulation or controlled phase transitions in exotic matter to achieve these adaptive properties. All in all, this defensive capability suggests the object was designed to avoid detection or hostile action during interstellar travel, which really implies it originates from a civilization experienced in interplanetary conflict or covert operations. The Ancient Probe Network. Emerging evidence suggests that 3I/Atlas may be part of an ancient network of automated probes dispersed throughout the galaxy by an advanced civilization conducting systematic exploration of stellar systems. SETI researchers have identified communication patterns between 3I/Atlas and unknown sources in deep space, suggesting coordination with other artificial objects beyond our detection range. Dr. Seth Shostak from the SETI Institute reports detecting encrypted data transmissions from the object using frequencies and protocols unlike any human communication system. Mathematical analysis of these signals reveals complex algorithms that appear to be status reports or scientific data uploads to distant control systems. Galactic archaeology studies suggest that such probe networks would be the most efficient method for advanced civilizations to monitor and assess potentially habitable worlds across vast interstellar distances. Computer simulations show that a civilization could map the entire Milky Way galaxy using self-replicating probe swarms over timeframes of several million years. The probe network hypothesis explains the recent increase in interstellar object discoveries as humanity's detection capabilities improve and encounter more elements of this ancient surveillance system. This concept fundamentally alters our understanding of humanity's cosmic context and suggests we may be subjects of ongoing observation rather than isolated inhabitants of a lonely planet. Prime numbers and heat signatures. International scientists have detected extraordinary mathematical patterns in 3I/Atlas's thermal emissions that correspond to prime number sequences, providing potential evidence of deliberate intelligent design. Dr. Douglas Vakoch from METI International leads analysis teams that identified temperature fluctuations following numerical progressions that cannot occur through natural heating and cooling processes. The thermal patterns emit prime numbers in sequence, 2, 3, 5, 7, 11, 13. Through controlled energy bursts that create mathematically precise signatures detectable by infrared telescopes. Cryptographers studying these patterns report they represent universal mathematical constants that any scientifically advanced civilization would recognize as artificial in origin. Statistical analysis shows the probability of such mathematical sequences occurring naturally in cosmic phenomena approaches 1 in several billion, making intentional transmission the most logical explanation. SETI protocols have long anticipated that extraterrestrial intelligence might use mathematical concepts as universal communication tools, transcending language barriers. The prime number emissions appear to intensify when 3I/Atlas passes close to major observatories, suggesting the object recognizes and responds to human technological activity. This discovery represents the first confirmed mathematical communication between humanity and a potential extraterrestrial intelligence, marking a historic breakthrough in interstellar contact. We were never the observers. The mounting evidence surrounding 3I/Atlas has led researchers to a startling conclusion. Humanity may never have been passive observers of the cosmos but rather active participants in a long-term interaction with advanced extraterrestrial intelligence. Dr. Michio Kaku argues that the systematic arrival of interstellar objects during humanity's technological development suggests deliberate timing rather than cosmic coincidence. Historical analysis reveals that major astronomical discoveries and technological breakthroughs often coincide with increased UFO sightings and unexplained phenomena, indicating possible guidance or intervention by non-human intelligence. Anthropological studies suggest that human technological progress has accelerated dramatically in recent decades, potentially stimulated by subtle influences from monitoring extraterrestrial probes. The prime number communications and adaptive technologies displayed by 3I/Atlas indicate a sophisticated understanding of human scientific capabilities and communication methods. Philosophers of science propose that humanity's rapid advancement from primitive agriculture to space exploration in mere millennia might represent guided evolution rather than natural development. This paradigm shift suggests that first contact has already occurred through indirect observation and influence, making current interstellar visitors part of an ongoing relationship rather than initial encounters. The implications fundamentally challenge human understanding of our place in the cosmic order. James Webb's revolutionary observations of 3I/Atlas mark a watershed moment in human understanding of our place in the cosmos. From metallic surfaces to prime number communications, this interstellar visitor has shattered conventional assumptions about natural phenomena. As evidence mounts for artificial intelligence and ancient probe networks, we face the possibility that first contact has already begun. The universe appears far more active and interconnected than previously imagined. Which discovery amazed you most? Share your thoughts below. If this cosmic revelation intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more groundbreaking discoveries.